Here we're graphing reciprocal graphs, like y equals cosecant x, y equals secant x, y equals cotangent x. And the best way to think of the reciprocals is to really think of the originals. The calculator can graph these for you, like if we go to y equals and we type in, well, we don't have a button for cosecant, but we know that's the reciprocal of sine, so we could do 1 divided by sine x and take a look at that graph. Now your graph might not look like this. You might have to adjust your zoom. And so if your graph doesn't look like this, make sure you hit zoom and then number 7 for trig. So zoom 7 is how we get the trig view on our graph. Now I'm going to show you where we get this picture from. First, let me just throw it on there so we have that as a reference. Now, again, I know this is the reciprocal of sine, so because I know cosecant is 1 over sine x. So let me first kind of picture the graph of sine x. Sine x looked like this. Oops, I'm doing y equals sine 2x, a little too sharp. Sine x looked like this. You know, because we knew it was 0 at 0, it was 1 at pi over 2, or whatever your amplitude is, 0 at pi, negative 1 at 270, and 0 at 2 pi. Now, because this is 1 over sine x, wherever sine is 0, you're going to get those asymptotes that we saw with tangent, because that would be 1 over 0. Notice that that's what we have here on this picture, too, is these asymptotes separating these different parts of the graphs. And then you might also notice something that's happening that's interesting is if we're to draw it, it kind of is like this. And the reason for that is if you take whatever values you have, you take the reciprocal of that. You know, at 45 degrees, I mean, you can look at the decimals on your calculator and stuff like that, but sine of 45 degrees is rad 2 over 2, and so cosecant of 45 degrees would be 2 rad 2 over 2, and we see the difference in the decimals. Like for example, let me show you that on the calculator too. That we know sine of 45 degrees is 0.707, and so looking here, 0.707. You know, I didn't graph it perfectly, but it's probably about there. Cosecant, so 1 divided by sine of 45, that's how I do cosecant of 45 degrees in my calculator, is 1.4. So I'm further up, like 1.4. So I did a little bit too high. It's probably about there. But you can see from our graph that that's what's happening is that the sine graph and its reciprocal are connected at the amplitude points, because where sine is 1, the reciprocal of 1 over 1 is still 1. So where sine is 1, cosecant is 1. So where they are 1 and negative 1, they share that. But everything else is a reciprocal, and where sine is 0, you have your asymptotes. Now it's the same type of relationship for cosine. So let's look at that. I just need to move this graph out of the way. Let's get to my cosine and secant graph. We know secant is the reciprocal of cosine, so if I'm going to draw first my cosine graph, just so I have that here, and the points where cosine is 0 is going to be the asymptote, and where cosine is 1, and secant's also going to be 1, or it's negative 1. Secant's also going to be negative 1, like this. Like that. And then for cotangent, the reciprocal of cotangent is actually pretty easy to graph. It's very similar to tangent, where you know that for tangent we have asymptotes of 0, and I'm sorry, not 0. We have the asymptotes where cosine is 0 for tangent, because it's sine over cosine, and so that is at pi over 2 and 2 pi over 2. So our tangent graph looked like 0 to 1 and up through here, here, and here. That was your tangent graph, and where cotangent and tangent coming together is again the reciprocals. So where tangent is 1, cotangent is 1, and where tangent's -1, cotangent's -1. So these values are still there. But what happens is where something is undefined for tangent, like say really just a number over 0 is undefined for tangent, the reciprocal is 0 over a number which is 0. So the spots that tangent is undefined, the asymptotes, that's where cotangent is 0. Because the reciprocal of an undefined fraction is 0. And so we see that it's kind of shifted over, and cotangent itself has some undefined spots. That's where tangent is 0. So wherever tangent is 0, cotangent is going to be undefined. So wherever tangent is 0, cotangent is undefined. So cotangent is like this. And our calculator can also, draw a similar picture for us.